This is Rational Equations. I'm going to try to make this video a little shorter. I tried it a while ago and it ran over. We're going to need to use common denominators. We're just not going to keep them. Okay, here's the idea. By the way, this is an equal sign. It kind of disappeared there. For the common denominator for this problem, you've got an n, you've got 4n, and you've got 8. The common denominator is 8 and n. Well, instead of doing a big fraction with 8n at the bottom, we're going to multiply through by 8n. Now, I'm going to put 1 in the bottom so it looks like we're multiplying through by 8n over 1. I want you to see that the 8n is in the top. Now, we're going to maintain that structure of numerator times leftover. Keep your sign. Numerator times leftover. Keep your sign. Numerator times leftover. Okay? Now, let's distribute the 8n. Now, if you notice, the n's cancel here. The n's cancel, and all we get is the 8. So you still kept the 3. All right, come to the next one. When you get there, the n's cancel, and it's basically like you're saying 8n over 4n. They reduce to 2. Then you've got 8n over 8. Well, if you did that, it reduces and gives you n. All right, if you keep going, you just solve from here. 24 minus 2 equals 15n. That would be 22 equals 15n. N is 22 over 15. Now, one thing to keep in mind with rational equations is something called restricted values. Restricted values is the values that your variable cannot have. Basically, your denominators are not allowed to equal 0 because everybody knows that you can't have 0 in the bottom of a fraction. So, wherever your denominator has a variable in it, those cannot be equal 0. So think about it, like this one. N cannot be 0. And this is 4n cannot be 0. Well, if you divide both sides by 4, isn't it still n can't be 0? So that is our restricted value for this problem. N can't be 0. That means that our answer is perfectly okay. There's nothing wrong with 22 over 15. Okay? Let's keep going. We've got another one with monomials in the bottom. Let's see what our common denominator is. We have 7, 14, and 2. As for the constant, we need a 14. We also need an h. Let's put that over the 1 so that you can visualize a little bit better. Keep in mind we need numerator. Since that's a binomial, wrap it up. It's very, very important to remember to wrap it up. Then you prepare for your leftovers. Bring down your sign. Numerator, leftovers, sign, numerator. It's a binomial, so wrap it up. And then prepare for leftovers. So you've got everything prepared for figuring out what's left over. Now let's think. 14h over 7h. That reduces to 2. 14h over 14. Well, that reduces to h. 14h over 2h. Well, that reduces to 7. And then it's just a matter of solving your equation. It looks backwards, but you guys can do it. 2 plus 12h minus 3h equals 7h plus 28. So we have 2 plus 9h equals 7h plus 28. So let's see here. 2h equals 26. H is 13. Now we do need to check out our restricted values. It's not too bad. We have an h in the denominator here and an h in the denominator over here. But if you remember the other one, both places, if you did 7h can't be 0, the 7 divides out, so it's h can't be 0. And even in the other place, right here, every time that you have a number multiplied times your variable, it's going to divide out, and it's just going to be that that particular variable can't be 0. So if we get anything other than 0, it's perfectly fine. Now let's upgrade a little bit. We've now got some binomials and even a trinomial. Now you should be suspicious of this trinomial. What two numbers multiply to 10 and add to 5? Or excuse me, add to 7. That's going to be 5 and 2, signs are the same, both plus. You should have been highly suspicious anyway, right? Okay, common denominator is x plus 2 and x plus 5. Now, just think of the restricted values to start with. If you were going to do the restricted values, what can you not have? If you set that equal to 0, let's just think, x plus 5 can't be 0, so x can't be negative 5. And then x plus 2 can't be 0. It's kind of squishing. And so you can't have negative 2. So those are the things we can't have. All right? Now, let's put that over 1 so we know what's going on. We have our numerator times leftover, numerator times leftover, numerator times leftover. All right, we're ready to rock and roll. When we look at the first one, x plus 2's cancel, we get x plus 5. Go to the second one. X plus 5's cancel, we get x plus 2. Go to the next one. Everything cancels. Please tell me that that is 1. And cancel is not a good word. Let's use the word reduce. Everything reduces to 1 or simplifies. Reduce and simplify are much better words than cancel. Excuse me. So we have 4x plus 20. And we have 3x plus 6 equals 5. This doesn't seem too bad. Let's see here. Back up just a smidge. It's going to give me a negative 21. I'm going to divide it out. We get a negative 3. Is that okay? It sure is. I'm not allowed to have a negative 2. I'm not allowed to have a negative 5. But negative 3 is perfectly fine. All right, now, you do have to watch out for some strange little ones. This doesn't seem too bad, but it is a little odd. Since those aren't in the form of a fraction, go ahead and force them into that form. Now, your common denominator is kind of obvious because you only have one little oddball, and that's the y. So when you go through and you multiply through by y, it's not too bad. You can do the same structure of numerator, leftover, and numerator, leftover, numerator, leftover. Nothing cancels in the first one because you just have a 1 down there. When you get to the second one, the y's cancel. I'm using that same word. Let's say that again. The y's reduce. There we go. Nothing reduces on the third one or simplifies, so you still maintain your y. Now, here it gets interesting. I have y squared plus 6 equals 5y. Now, whenever you get y squared, hopefully you know that this creates an interesting problem. Since you have a quadratic now, you have to force all of your terms to one side of the equation and try your best to factor and solve. If you can't factor, you've got to pull out your good old quadratic formula and solve it. So hopefully we can factor. First of all, since this is positive, let's have everybody join him. So 5y needs to come over. And let's kind of worm him in the middle so that we have everything in descending order. So, does it factor? Hope so. That'd be so much easier. Two numbers that multiply to 6 and add to 5. That would be 2 and 3. Signs are the same, both of them negative. Okay, now that means y plus 2 equals 0 and y minus 3 equals 0. If you solve both of those, we'll get our solutions. We have a 2 and we have a 3. Are both of them permitted? Okay. Let's kind of go back up here. The only thing that is restricted, because our only denominator was y, so y could not be 0. So both of these are okay. We have 2 answers because we ran into a quadratic along the way. Remember fundamental theorem of algebra? Your degree is basically equal to the number of solutions you have. All right, our last example is kind of interesting because every once in a while you're going to run into a problem where you have one fraction equals another. In this case, you could actually cross multiply. It's only allowed when you have one fraction equals another. I'm going to work it out and explain it the same way we've been doing with a common denominator idea. The work on the page is going to look exactly the same no matter which way you do it. The only difference is going to be what goes on in your mind. So it really doesn't matter which way you think through it. It will look the same on the page. Let's see here. Our common denominators, a plus 5, a plus 1. When you multiply through, the a plus 5s go out, so I am left with a plus 1 here. All right, go over here. The a plus 1's cancel, and I'm left with a plus 5. Just back up and look. If you cross multiply, do you see that a and a plus 1 are matched, which is what we have? If you cross multiply, you have 3 and a plus 5. So it really doesn't matter which way you think it's going to work out the same way. All right, same problem. We have a quadratic. So since it's a quadratic, everybody needs to join it. Now we have two linear terms. We have an a and we have a 3a. So they need to get together. So 3a needs to come join. And the reason I'm moving the 3a is because we need everybody to come over here with a squared. So even though 3a is larger, he needs to move. And the 15, he has nobody to go with, so he just has to jump. So sign's got to change, and there's our lovely 0 that we have to have. Okay, time to factor. We need two a's. What two numbers multiply to 15? Subtract 2. That would be 3 and 5. Signs are different, and the big one is negative. All right, basically you end up changing your signs. So a is equal to a negative 3, and a is equal to a positive 5. Are they okay? Because we didn't talk about restricted values. Remember, it's basically the opposite sign. So a can't be a negative 5, and a can't be a negative 1. So both of our answers are perfectly legit. Okay, hope this helps.